Thus far, we have had an introduction to statistics, and we've also looked at how data is stored for statistical analysis, namely in the form of data frames. In this lecture or in this module, welcome back. We have taken a look at an introduction to statistics, and we've also looked at how we store data in the form of data frames for statistical analysis. Let's take the next step and look at how we can generate interesting data graphics from data frames. So that's the lesson. And the first thing we're going to look at is how to generate what are called as point plots. Now, point plots are also called as scatter plots, and they are the most basic representation of two-dimensional data. And of course, when we plot data, what we are looking at is we are trying to look for patterns in the data that will help us wrap our head around some of the structures implicit in the data. So if we are given a data set like this, in which there are 5 variables: age, height, weight, distance, and gender, and there are 10 specimens or instances. Okay. Now, it's difficult for us to spot patterns in this data set, even though this is an extremely small data set. Normally, data sets would contain hundreds, thousands, or even hundreds of thousands of rows. Okay. So if we can't wrap our head around this small data set, there's no hope of us just looking at data and trying to spot underlying patterns. So we might have all sorts of questions. Okay, so do males in general throw farther? The distance is, how far each of these people is able to throw a shot put of a certain weight. Now, this data set could be a data set of, let's say, students. Each row is a student. So, student is our unit of observation. And for every student, we've got age, height, weight, gender, and the distance to which they threw a shot put of a certain weight. Okay, so we may have questions like, do males in general throw farther? Okay, now of course you may just look at the data and calculate the average distance for males and females and see if the average for males is higher or not. But that's not really uh, sufficient. That may be misleading because it is possible that in this data set you've got males who are generally older than the females. Okay, so just because the average distance for males comes out to be higher, we cannot generalize and say yes, males do throw further because uh, you looked at older males in comparison with younger females, and that could be a cause for why it turned out to be higher. If it does turn out to be high, I don't know. Okay, so the point is that just looking at the data is not enough for us to answer these sorts of questions. We need deeper analysis. Similarly, are females in general taller, right? And even after adjusting for ages, it should be ages, not ager. Okay, which means that uh, obviously, if in our data set the females are generally older, then there is a good likelihood they would also be somewhat taller. If they are much older than the males, then they could be taller, right? But even if we manage to adjust for the age, are females still taller or shorter? So you may have these kinds of questions. For example, is there a relationship between height and weight in general and also within each gender? In other words, uh, we may think that people who are taller are also heavier overall as well as within each gender. Okay. Now, another question might be which has a greater impact on the distance that somebody is able to throw a shot put? Is it weight or is it age? Or maybe is it height? Okay. So there are all these sorts of questions that we may ask when we are given a data set like this. And even with just 10 rows, it's not possible for us to look at the data and come to any definitive answers to each of these questions. So that is why what we do is typically when we get a data set, the first thing we do is to visualize the data, generate certain graphics, and see if the graphics show us some underlying patterns. Okay, like I said, the most basic of graphics is a scatter plot, or what the course text calls as a point plot. Okay, so here's another data set where we've got people again, The unit of observation is a person, and you've got for each person the height, weight, the state from which they are, the age, and gender. These are the five, six variables in this data set. Okay, but in this case, we are only interested in studying the relationship between the variables height and weight. Okay, is there a relationship between height and weight, or are they completely independent of each other? That's what we want to do. Okay, so since we are concerned only about height and weight, let's just look at those two variables and forget about the other variables for the time being. Okay, so we've got the height and weight. How can we visualize this? In other words, how can we make the pattern, if there is any pattern, how can we make the pattern become very obvious and pop? Okay, so let's see how we can visualize the data. Let's say we take the first person in this data set who's got a height of 178 centimeters, 75 centimeters, and a weight of 70 kilograms. How can we represent that? One way to do that would be to uh, consider plotting it on a two-dimensional plot. So we put height on the x-axis, we put weight on the y-axis, and every person will be represented as a point in this two-dimensional space. Okay, so the first person is 175 centimeters tall. Okay, so we can just draw a line from 175 centimeters. Okay, and then they are 70 kilograms, so we draw another line, and therefore at the point at which these two things intersect, we can represent them with a point plot there, with a point there. Okay, so this is one way of putting a point and capturing both the height and weight simultaneously, so that it makes it easy for us to visualize things. Okay, similarly, we take the next person, 160 and 55. So once again, we've got this vertical line going from 160 and 55, where they intersect is where I've put a point for the second person. Similarly, for the third person, who is 180 and 80, that is where those 2 points intersect, and so on and so on. We can plot. The next one is 165, 60. So that's where that point falls. And in this fashion, we can plot all the points. Okay, so every person is represented as one point in this point plot or scatter plot. And now the trend becomes pretty obvious to us, right? We can see that people who are taller in general are also heavier, right? So take this person, they're pretty tall, they're also pretty heavy. So as we go to the right in terms of height, we can also see that we are going up in terms of weight. Okay, so people who are taller generally are heavier, people who are shorter are generally lighter. That's the trend, which was not obvious in looking at the data. Okay, so it becomes obvious once we plot it. Now again, we are only saying this is a trend, that people who are taller are generally heavier, but this is not always the case. So for example, this particular person is actually taller than this person, okay, because they are to the right. However, they are not heavier, they are lighter. Okay, so this is an example which runs counter to the general trend of the data. This is another such example which runs counter to the general data. Okay, in this data set, those are the only two counter examples. All other points follow the general pattern of heavier people, taller people being heavier. Okay, so here you're seeing how when you plot the data, some patterns come out, and that is why we call this as exploratory data analysis. It's almost always the first step in data analysis. Just look at the data and form some hypotheses. Okay, now if when we have patterns like this, we are saying the two variables are related, but we are not making any statement about whether one variable caused the other variable to change, right? Is it that being taller causes the weight to be higher? Okay, or is it the other way? Is it that people who tend to become heavier tend to grow taller? We cannot make causal inferences, we are only seeing patterns. Okay, so data visualization enables us to develop certain hypotheses, which we will then test more rigorously using statistical techniques. Okay, for now, we are happy that we found a relationship, and it helps us to better understand our data. Okay, now what is the convention? Why did we put height on the x-axis and weight on the y-axis? Okay, the convention to determine axis is typically we want to say what is the effect that one variable has on another variable. Okay, so here we are saying what is the effect of height on weight. Okay, so in this case, we are looking at weight as kind of the response variable and height as kind of the explanatory variable. Okay, so the response variables we generally put on the y-axis. Okay, so that is why here we put height on the x-axis and uh, uh, and weight on the y-axis because weight is the response. So we want to say the effect of A on B. So B is the one that is being affected and A is the one that is affecting. Okay, so the affected variable is what we call as the response variable, and we tend to put that on the y-axis. It's just a convention. So if our question on the other hand was effect of weight on height, then the plot would have been different. We'd have put height on the y-axis and weight on the x-axis. Now these two plots are absolutely equivalent in terms of the information that they convey to us. Okay, but it's just a convention to put the response on the y-axis. Okay, let's jump right into how do we generate these point plots. After all, earlier we generated the point plot manually. Now that is not possible. Even for this data set of 10 rows, that was an involved process. And if you have a data set of 5,000 rows, forget about it. You cannot do it by hand. It's just going to take way too much time. Fortunately for us, uh, statistical software can do all of these things very, very nicely and easily. We are going to be using the statistical software called R in this course. And of course, we already saw some examples of using R with our BERTS 2022 data set. Okay. Now R is very powerful for plotting, and let's take a look at how to plot some data using R. Okay. Now remember, we are going to use in this particular example the data set called anthro_F, which is anthropomorphic data from college-aged women, F, female. Okay, so that's the data we have. This has, I think, 20,000 rows, and we want to use this to practice some plotting. Okay, now how do we get the code book for this data set? Meaning, how do we know what are the columns and what each column represents? We can always do what we learned earlier, which is !anthro_F, and that will print out the data set. That will print out the data set. Okay. Now, if you want to do a point plot, all we have to do is to use the function called point plot. Okay. So we say anthro_F, and then we use the pipe sign. Remember, we learned how to pass a data frame to a function. We use the pipe. So we are doing that. We're taking this data frame, and through a pipe, we are sending it to the function called point plot. Now, this data frame has many, many columns. I think it has like 50 columns, okay, or at least 35, 40 columns. It's got a lot of columns. Now, if you want to generate a point plot, obviously from all the columns that it has, we have to identify the two columns that we want to plot, the two variables we want to plot. Okay, that is because a point plot can only show you 2 points, the two variables. One goes on the x-axis, the other goes on the y-axis, period. That's it. Okay. So obviously, if you want to do a point plot, you have to tell it what goes on the x-axis, what goes on the y-axis. Okay. In this example, we want to study the effect of ankle sizes on the wrist sizes. In other words, we want to see the relationship between ankle sizes and wrist sizes. And let's say that wrist size is our variable of interest. It is our response variable. Okay. So we are going to say point plot wrist tilde ankle. Okay, this is called as a formula expression in R. Okay, this is like saying put whatever you put first will go on the y-axis, whatever you put second will go on the x-axis. That's just the convention, right? So we say anthro_F pipe point plot wrist ankle. Okay, so you see ankle goes on the x-axis, wrist goes on the y-axis, and lots of data points have been shown here. Okay. And you can again see a general trend, right? The general trend is sloping upwards and to the right, which says that people who have larger ankle sizes also tend to have larger wrist sizes. It's just the general trend, but of course, there are lots and lots of exceptions to the trend. Okay. So this argument to this function, the first argument to the function, of course, is the anthro f data frame. The second argument to the function is we are telling it, okay, I want you to give me a point plot, and the way in which we specify what goes where, what goes on the x-axis, what goes on the y-axis, we specify it using an expression like this, in which you've got something tilde something. Tilde is the name for this particular character. Okay, so whatever is on the left of the tilde goes on the y-axis, whatever is on the right of the tilde goes on the x-axis. Okay, so that is how we specify to the point plot function which variables to plot and where to put them. Okay, so that's about it. That's about uh, using R to generate point plots, and also why we want to visualize the data to see underlying patterns.